Alright, we're starting chapter 8 with applying exponent properties that involve products. Our first property is if we have product of a to the m times a to the n, where a is a similar base, then our answer is a to the m plus n, so we add the exponents. So I'll do an example not with a's and n's, so you can figure out what to do with numbers. If we have 4 squared times 4 to the third, what we do is keep the base the same, so it's 4, and then we add the 2 and the 3, so it's 4 to the 5th. Okay, so these examples are below. We have 7 to the 8th if we add the 3 and the 5. On B, we just have to be careful that the first 9 actually is 9 to the 1st, and then when we add all those exponents together, it would be 9 to the 11th. C, again, this negative 5 is to the 1st, so it's negative 5 to the 7th, and make sure that you put that negative 5 in parentheses, because if you just have a negative outside, these are not the same thing. So you cannot use that. We have to have parentheses around the negative 5. So even with x's, that's a similar base, so now we can add the exponents. X to the 7th. E is 3 to the 9th. And F is x to the 9th. Remembering that there's a 1 right there with that x. Okay, the next one, if we find the power of a power, we multiply the exponents. That is saying, if we have a to the m, and we raise that whole thing to another exponent m, n, instead of adding like we did before, we actually multiply the two exponents together. So it's m times n. So with numbers, let's do an example. If we have 3 to the 4th, that whole thing squared, that turns into 3 to the 8th. Okay, so similarly with these examples down below, we multiply the exponents, so it's 2 to the 15th for A. B would be negative 6 to the 10th, remembering your parentheses. C is x to the 8th. And D, our base is just the y plus 2, so we don't actually do anything different other than treating that like a negative, keeping it in the parentheses, y plus 2 to the 12th power. Our next property is the power of a product. So if we have a product a times b, and that's being raised to the mth power, then we find the power of each factor on the inside and multiply. So that's a to the m times b to the m. So that's almost like doing the distributive property with the exponent to every term inside of our parentheses. So if we had 23 times 17 to the 5th power, that would be 23 to the 5th times 17 to the 5th. And we do not have to actually multiply those out because this would be a very large number and we don't actually have to use that. All I want to see is that you know how to use the properties. So if you leave your answer in terms of exponents, that's showing me that you know what you were doing, not just typing it in the calculator. So let's use that property, kind of distributing that exponent. So it's 24 to the 8th times 13 to the 8th. B, 9 squared times x squared times y squared. In the case like this where you have variables and numbers, it might be nice to simplify just the number part of it. So 81 x squared y squared, as long as it's not going to be a huge number like 13 to the 8th, we're not going to actually want to distribute that. C, so the negative just goes with the 4, doesn't go with the z also. So when we distribute that squared, that's negative 4 squared times z squared. And similar to b, we can actually figure out what negative 4 squared is, which is 16. And we can leave our answer like that. D is a little bit different though because the negative's on the outside. So we know that we're just going to have a negative answer. So negative 4 squared times z squared. 4 squared is 16. And we know we have to have that negative outside because the negative was on the outside of the parentheses, not included with the 4. Okay, now we're going to use all three properties that we just learned. The first thing that I'm going to do is get rid of the parentheses if I'm following order of operations. So I'm going to distribute that squared into both terms inside of our parentheses. So that's 2 squared times x to the 6th, because we multiply those exponents, times x to the 4th. And then I need to multiply the x to the 6th and the x to the 4th by adding the exponents. I can also just figure out what 2 squared is. That's easy. So our answer is 4x to the 10th. In 2003, the USDA collected data on 10 to the 3rd honeybee colonies. If there's 10 to the 4th bees in each colony, how many bees were in the study? So we just need to multiply those two numbers, 10 to the 3rd times 10 to the 7th. Oops, got ahead of myself. Times 10 to the 4th is 10 to the 7th. And with 10 as your base, it's easy to multiply out and figure out how big your number is, because that's how many zeros there are, whatever the exponent is. So 1, 2, 3, 4, 5, 6, 7 bees. You can leave it either way, either as an exponent or multiply it out using the zeros. And that was all in section 1.